Hi everyone, welcome to the first session of chapter 7, the world of carbon, 9th standard chemistry. Carbon is a well-known non-metal. Almost all the materials that we use in our daily life such as clothes, food, fuels, cosmetics, medicine, paper, rubber, plastic, everything contains carbon, and it is also an essential component present in all living organisms. The element carbon exists in different forms with wide varieties of physical properties. It exists in the combined state as well as in the elemental form in nature, and it is abundantly present in the earth crust. The charcoal that is left behind after the combustion of a substance is due to the presence of carbon compound in it. The black smoke that is given out when some substances are burned is also due to the presence of carbon. In our periodic table, carbon is represented with the symbol C. Its atomic number is 6. That is, it has got 6 electrons and 6 protons. Carbon belongs to 14th group. So, there are 4 electrons in the valence shell of carbon. So, today in this session, we will discuss about allotropes of carbon. Now, let us see what is allotropy. Different forms of the same element having different physical properties but with same chemical properties are known as allotropes, and this phenomenon is known as allotropy. Let us see the allotropes of carbon. Carbon exists in 2 allotropic forms. First one is crystalline allotrope of carbon and second one is amorphous allotrope of carbon. The difference is that in crystalline allotrope, all the constituent particles possess a definite order of arrangement. So, that is clear from this figure. Then, in the case of amorphous, they do not possess any definite order of arrangement. They are arranged in a random manner. Now, let us see the crystalline allotropes of carbon. They are diamond, graphite, fullerenes and graphene. Now, let us discuss in detail about each. So, first one is diamond. Diamond is the hardest allotrope of carbon. First of all, let us see the structure of diamond. So, it has got a 3-dimensional structure. In diamond, each carbon is covalently linked with 4 other carbon atoms. This strong bonding is responsible for the hardness of carbon. And we know that in the outermost shell of carbon, that is the valence shell, it has got only 4 electrons, and those 4 electrons are covalently bonded with other 4 carbon atoms. So, there is no free electrons present in diamond. Because of the absence of free electrons, diamond is not a conductor of electricity. Now, let us see what are the characteristic features of diamond. They are very hard, transparent, not a conductor of electricity, high thermal conductivity, that means it has got high ability to conduct heat, then high refractive index. Then the main uses are, they are used to make ornaments. Because of their luster, they are used to make ornaments. Then it is used for cutting glass. Since diamond being very hard, it can precisely and accurately cut glass into definite form or shape. So, the second allotrope of carbon is graphite. So, it is the softest allotrope of carbon. So, this is a structure. So, here in graphite, each carbon is covalently linked with 3 other carbon atoms forming hexagonal rings, and they form a sheet like structure. So, these sheets or layers are placed one above the other, and there is no covalent bonding present between these sheets. There is a weak van der Waals force present between these sheets, so they can slide over one another. In the case of graphite, we know that carbon has got 4 electrons in the outermost shell. Out of the 4 electrons, 3 of them will form covalent bond with the neighboring carbon atoms, and 1 electron is left. So, that is a free electron. So, there are free electrons with carbon atoms in the case of graphite. So, because of the presence of this free electron present in their structure, graphite is a very good conductor of electricity. Now, let us see the characteristics. It is soft and slippery. It is grey in color. It's a conductor of electricity and it is non-volatile. Non-volatile means it is not easily converted to vapor state. Now the uses. Graphite can make marks on paper, so it is used to make pencil lead. Then second use is it is used to make electrodes in dry cells. We know that because of the presence of free electrons, it is a very good conductor of electricity, so it is used to make electrodes in dry cells. Then the last one is it is used as a solid lubricant. It is because of its slippery nature, it is used as a solid lubricant. Now let us see another allotrope of carbon, that is fullerenes. So this is a structure of a fullerene. Chemically, fullerenes contains large number of carbon atoms. The first fullerene identified is C60. It contains 60 carbon atoms. The structure was established by an American architect, Buckminster Fuller. So fullerenes are often called as buckyballs. So fullerenes has got a hollow structure containing hexagons and pentagons. So you can see hexagons and pentagons in this figure. Then fullerenes with cylindrical structure are called carbon nanotubes or Bucky tubes. So the main use of fullerene is it is used in the field of information technology. Now let us see the last crystalline allotrope of carbon, that is graphene. So this is a structure of graphene. So graphenes are two-dimensional sheets of hexagonal rings made with carbon. It resembles a single layer of graphite. And it is also considered as the basic unit of some of the allotropes of carbon such as fullerene and graphite. Now let us see the characteristics. It is 200 times stronger than steel and it is a very good conductor of heat as well as electricity, and it is used in the field of nanotechnology. Let us see the second category of allotrope of carbon, that is amorphous allotropes. So we have coke, coal, charcoal, lamp black, etc. These are the amorphous allotropes of carbon and they are commonly known as amorphous carbon. So let me conclude. So today we studied about allotropes of carbon. Carbon exists in two allotropic forms: crystalline allotropes which possess a definite order of arrangement and amorphous allotropes which do not possess a definite order of arrangement. The crystalline allotropes are diamond, graphite, fullerene and graphene, and the amorphous allotropes are coke, coal, charcoal and lamp black. So that's all. Thank you.